To help you learn faster, I have linked the video that inspired this tutorial at the end. It shows a different approach to the same problem. As always, you'll see keyboard shortcuts in the bottom left corner. We'll start by following the first rule of Fusion: create a new component. Start your bottle prototype with the sketch on the horizontal construction plane. Use the center diameter circle and place it at the origin. This keeps your design centered on the construction planes. Set the diameter to 100 mm if you want to follow along with my dimensions. Next, draw a line through the center of the circle, turn it into a construction line and trim away 1/2. We're focusing on just one side of the bottle and will mirror it later to complete the shape. Next, create the path that defines your bottle's shape. Start at the origin and switch your view to look directly into the open side of the half circle. Begin a new sketch on the vertical construction plane facing you. The fit point spline works great here. It's easy to shape and fine-tune using the green handles. I'm using 50 mm for the dimension, but that's just for demonstration. Once you're done, you should have a half circle and a spline that curves upward and to the right. Use the surface modeling sweep command for this operation. You'll recognize it by the orange icon, which tells you it's a surface feature. And that's important here, since we're sweeping an open profile. Select the half circle as your profile and the spline as your path. You can leave the default settings as they are. Like most tools in Fusion, Sweep has more options under the hood, so make sure to explore them when you have time. Take a moment to look at your model from different angles using the ViewCube. Then, position yourself in front of it using the left view. Create the sketch on the vertical construction plane facing you. Press and hold the mouse wheel to pan and make sure the entire model is visible before moving on. Place a 3-point arc so it slightly overlaps the existing geometry. I'm using the arc tool here because it gives the shape I'm aiming for, but feel free to experiment with other tools if you're after a different result. You can adjust the arc's radius using the dimension tool, useful if you're designing something with specific product requirements. This sketch isn't fully defined yet, which means you can still move it freely by clicking and dragging with the left mouse button. Now use the offset tool to create a second arc and set the distance between them to 10 mm. From here, you only need to adjust the first arc to control both curves. Change your view using the ViewCube to get a better sense of how the arcs line up with the surface model. Now use the surface modeling Extrude command. Remember, we're still working with open profiles. Extrude the arcs far enough so they fully cover the existing geometry with a bit of margin. These surfaces will be used as tools later, so there's no need to fine-tune the extrusion to match the first surface model exactly. Next, use the split face tool to divide the original surface. Set the original surface as your face to split and use the two extruded arcs as the splitting tool. After the split, you'll have 4 surfaces. the two splitting tools and the original surface now divided into two parts. Delete the new surface that was created by the split and hide the two arc-based surfaces you used as splitting tools. Let's push the smaller of the two visible surfaces inward while keeping the proportions intact. Use the offset face command and set the distance to -5 mm. This creates a new surface body that sits slightly inside the original. Now use the Loft command from the surface modeling tools to connect the two surface bodies. The G0, G1 and G2 options control how curvature, tangency and radius are blended at the junction. For this example, we're going for a straight connection, but it's good to know these settings exist. They're beyond the scope of this tutorial, but definitely worth exploring as you get more comfortable with surface modeling. Rotate your model and check it from different angles, then use the ViewCube to snap to the left view so you're looking straight at the surface model. Create a new sketch on the vertical construction plane behind your model. Press and hold the mouse wheel to pan and reposition the view if needed. Use the project command to bring in a linked sketch line from the top edge of your bottle prototype. Then use the offset command to create a line 20 mm away from it. Right-click on the canvas and choose Repeat Offset to make a second offset at 25 mm. You should now have two linked lines on the vertical construction plane behind your surface model. These lines serve the same purpose as the arcs you created earlier. They'll be used as cutting tools. Use the Surface Modeling Extrude command since we're still working with open profiles. To extrude both lines straight through the surface model, make sure to extend them with some margin so they fully intersect the geometry. Use the Split Face tool to divide the surface again. This time you likely run into an error, but I've left it in the tutorial on purpose because troubleshooting is a key part of learning Fusion. The split face operation fails and the error message gives a hint why. Editing the extrude feature doesn't solve it, but adjusting the underlying sketch does. Simply drag and extend the sketch lines so they fully cover the surface model with a good margin. Once that's done, return to the Split Face command. Make sure Split Type is set to split with surfaces, and the tool should now work as expected, dividing the surface into new, clean surface bodies. Nice work! You've successfully completed the split face operation. Now hide the splitting tools to keep your workspace clean. Select the new surface body and use the offset face command. Set the offset to -2 mm to push it slightly inward, placing it just inside the surface it was created from. Add subtle fillet of 2 mm to soften the edge. I'm using the default settings here since the focus is on the overall process of building the prototype. You can always fine-tune the details later. If you used different settings the last time you applied a fillet, Fusion might remember those, so don't worry if your options look slightly different. This is a great time to save your project before we wrap things up with the final details. Getting into the habit of saving regularly can save you from a lot of frustration later on. Click and drag from left to right to select all the surface bodies you fully enclose in your selection box. Then use the mirror command to mirror the selected surfaces across the construction plane in the middle of your model. Leave the tolerance setting as it is. That's fine for this prototype. And be sure to set the operation to join. Once your mirrored surfaces are in place, use the patch command to close the top and bottom of the model. This creates a sealed boundary around your entire design, ready for the next step. Just like with other commands, the default settings often work well, but don't overlook the chance to fine-tune them for more advanced modeling or precise results. To stitch your surfaces and convert them into a solid model, the surfaces must form an enclosed shape that can be stitched together. That's why we used the patch command earlier, to make sure the model was ready for stitching. Once you confirm the stitch operation, the surfaces will turn into a solid body, and you'll see that update in the project browser. Let's finish strong by improving the grip on this bottle prototype. Start a sketch on the vertical construction plane at the center of your solid body. Project the edge of the solid body and leave the projection link turned on to capture future updates. The projected line, shown in purple, makes it easy to place a center diameter circle directly on it. Sketch a circle with a 10 mm diameter positioned 27 mm from the top of the projected line. Then use an extrude cut operation. Extrude symmetrically to cut through both sides of the bottle. There's no need to match the extrusion exactly to the width of the bottle. Just over-extrude it to capture everything, including any future changes to the bottle's thickness. Now, create a pattern on path. Using the pattern on path feature in the solid modeling environment has big advantages over doing it in the sketch, like easier editing later. As a rule of thumb, keep your sketches simple. Set the orientation to follow the path direction and choose the compute type optimized for a smoother workflow. Set the quantity to 6 to give the bottle better grip and flexibility when holding it. Let's finish with a few important tips. If you want to apply appearances to individual faces, set Apply To, Faces. Adding appearances before mirroring the body has an advantage. The mirrored side will inherit the same appearance. The video that inspired this tutorial is linked at the end. If you want to support the channel, feel free to subscribe, like, super like, or leave a comment. Good luck 3D printing your prototype, and see you in the next tutorial.